Father, in the name of Jesus, I want to thank you for the gift of life. I want to thank you for the new day you are giving us today, Lord. As we are going to continue with our lesson, may you make it be fruitful to all of us, so that at the end, all of us are able to gain. I pray all this in Jesus' name. Amen.
Amen. Thank you so much. You are going to allow me to disable some features such that we do not have that background noise for people. Yes, but in case you want to say something, or you feel free to say something. So those people who were not here last time we were looking at the integration of trigonometric functions. That's where we ended, and that's where we are going to build from to continue with how we integrate trigonometric functions. Those who have been very observant and have been able to make some revision, I think you have noticed that there is a lot of trigonometry in many of the sections of the paper, be it paper 1, be it paper 2. When it comes to numerical methods, you'll find something concerning trigonometry and also integration. So that's why we think you must first understand this topic and other topics, but this topic is going to be very important. The first screen I have displayed, these are some of the basics you need to know before we dive deep into the paper. So before we dive into today's trigonometry, you need to know those basics, that when I integrate sine, I get negative cos. When I integrate cos, I get sine. So those are some of the basics that we are supposed to be knowing before we dive into the paper. But you don't need to cram all, but at least you need to know the basics, such that at least you do not waste a lot of time checking in your logbook for in the math booklet, looking out for some of these basics. At least please make sure at least you know those three of your head, that even when they wake you up, at least you know what you obtain when you integrate with those three. These three are the basics, then the rest can come in. But at least make sure you know what happens when you integrate sine and when you integrate cos. Then the rest can come in. So those ones, know them in the head. But in case you reach the paper at times and you feel you are not sure, then ask for the booklet, for the logbook, and then look out for those formulas because they're always given to you. So what is our focus today? Our focus today is the integration of the product of two cosines or sines. So we have integration of trigonometric functions, but they are of different stages. So today we are going to first focus on what we call integration of the product of two cosines or sines. So let me ask you to first write, and then we dig deep into today's lesson. So first write that as your heading, write that what you are seeing, and then we start. So when they talk about product, they're talking about multiplication. That what happens. So an example of what we call the product. I think some of you have been meeting integrals where you have sine x, you have cos x, something like that, dx. Yeah, maybe, yes. So this is a product of sine and cosines. But now this one is very easy. We can do it. Some of you have been meeting integrals whereby we have, we have sine 2x, cos 3x, dx, whereby when you look at the angle is not. So I know many of us can do this type of integral. But what happens when we have 2x cos 3x? What do we do? So now in today's lesson, this is where we are going to focus on. You have been meeting integrals where you find cos 5x, cos 3x, and you ask, how do I attempt that? So this is where our focus is going to be today, and then we shall be able to proceed from there. So that is where we are going to start from, and then we shall be able to build up from there. So I want you to finish that, and then when you finish, you let me know, and then we'll start. When you finish, just type in the chat, "I've finished." Okay, I think okay, people have finished. Good, good, good. Yes. So now we are going to dive into what we are supposed to do today. Now, before we integrate these functions where we have sine to x cos 3x, one thing we need to know is what we call the factor formula. Anything you're going to deal with when it comes to these ones, it's going to be the factor formula. It's going to be a key thing. And it is from here, that's where we are going to start from. And then we shall build on slowly. Well, after you understand, remembering how to use the factor formula, we can build on. So I'm going to start from the ones I feel you might be remembering. So we know when I have cos A plus B, when we expand, someone can raise up the hand and tell us, when we expand cos A plus B, what do we get? Raise up the hand and you tell us. Yes, Dennis.
We get cos A,
Cos A,
cos B,
cos B,
minus sine A,
minus sine A,
sine B.
sine B. Very good. Thank you so much, Dennis. Can we have now another person to tell us, what if we had A minus B? When we expand, what do we get? Someone? Another person? Raise up the hand and you tell us. Probably God. Yes, okay. Yes, Kusima.
Cos A,
Cos A,
cos B,
cos B,
plus sin A,
plus sin A,
sin B.
sin B. Thank you, Kusema. Now, members, we are going to build from here. And what are we going to do? We are going to find out when we add these two, what do we obtain? Now, I'm going to come, I add them. So when I add, I'll have A plus B plus cos of A minus B, 9. Okay, minus B is equal to, when you notice, members, this is cos A cos B, cos A cos B. So they are the same things. So when I add, I'll get 2 cos of A cos of B. When I come this side, this one is negative, this is positive. This is sin A, sin B, sin B, meaning that these ones are the same terms. So since one is a negative and another one is a positive, once I add them, I'll get 0. So I remain with 2 cos A, cos B. Members, is that step fine? Where I've reached in red? Kindly let me unmute and let me know. Is that step fine?
Yes.
Yes. Okay. Now we are going to continue. Now, from this point here, what do I want? I want you now to take note that when I divide through by 2, I divide through this side by 2. This 2 and this 2 is going to cancel. So allow me to write it in a good mathematical way as a half into cos of A plus B plus cos of A minus B, everything in the bracket, because this half affects everything, should equal to cos of A cos of B. Members, is that step fine?
Yes, sir. It's fine.
It is fine. Eh? Now, members, I want you to put, in fact, I want you to put that thing in a good way, that this thing is going to be very important. In that, whenever we are going to be meeting cos A cos B as our integration function, then we shall be applying this. Are we together?
Yes.
Okay. Can I first give you an example on that? Or we first complete deriving them?
We first
We
complete.
first
Yes?
we
We
first
first finish.
We first
we first
complete.
derive.
Okay. Now that is one. Now, members, the next one is yours. I have derived for you one. Members, I want you to get the same two functions. Instead of adding, I want you to subtract. And tell me, you are going to share with me what you get as your resultant. So instead of adding, I want you to get these two functions and instead subtract. Have you understood the instructions? Yes. So work out now. We are subtracting the two. We are subtracting the two. Subtract, everyone, you should be able to try. So the first one we added. The second one, I want you to subtract. I want you to subtract. When you finish, you can raise up the hand and you share with us what you have. When you finish, feel free to raise up and you tell us the result you get, okay? Yes or Chen?
We get -2 sine A sine B.
You get?
-2 sine A sine B.
Sine A, sine B. Is equal to? Okay.
I've got one part.
Okay. Yes, Jemima?
Teacher, I get -1/2 into brackets cos A plus B minus cos A minus B close bracket sine A sine B.
I beg
Is
you,
equal
cos
to
A
sine
plus
into-
B?
I get -1/2 into brackets cos A plus B minus cos brackets A minus B, then close brackets is equal to sine A sine B.
Equal to sine A, sine B. Okay, thank you, Jemima. What about the rest? Are we getting that also? Is everyone getting that? Yes, there's someone here. Yes, you can tell us also. Oh, yes, share. Yes, share. Oh, okay. Yes.
Can I say what I have?
Okay. That is okay. Yes, Jemima, this is very okay. This is very okay, but I want us now to make it a bit more beautiful. Now, to make it more beautiful, I want us to ignore this negative. So I'll have a half.
So
That negative, I'm going to put it inside. So I get negative cos of A plus B plus, because it is a negative, it multiplies here and it also multiplies here. So here I will get plus cos of A minus B is equal to sine A sine B. Now, what is going to happen that I can start with a positive. So I can write out a half into cos of A minus B minus cos of A plus B is equal to sine of A sine of B. Yes. So, but don't feel bad to leave it like the way Jemima has left it. It is also okay, as long as you don't forget that negative. So this is our second identity. I want you to keep note of.
But it will.
Yes. So keep note. Keep note of that. Then now we are going to the third one, to the third identity. Yes. So now we are going to the third one. Now the third one, we are going to use the signs. We know very well that when I have sine of A plus B, members, can someone raise up the hand and you tell us, when you have sine A plus B, what do you get? Let me see. Okay. Yes, Dennis.
We get sine A cos B. Sine A cos B plus sine B sine B cos A.
Cos A. Okay. Members, do we agree? Do we agree? Someone can tell us. What if we have sine of A minus B? Members, what do we get? Another person. Thank you, Dennis. Another person. Okay. Yes, Jemima.
So you get sine A cos B minus sine B cos A.
Sine A cos B, minus sine
B cos A.
Cos A, good. Now, our task still, we are going to do the same, to add or subtract any of the two, but adding. Now, what happens is that when I add, what will I get? This side, I'll end up with sine of A plus B plus sine of A minus B is equal to, now, sine A cos B, meaning that these two can be added, so we end up with sine of A cos of B. Then a plus and a minus, since it is sine B cos A cos B, since I'm adding, it will vanish to add 0. So I'll end up like with this. So meaning that now I can summarize by removing the 2, and I end up with a half into sine of A plus B plus sine of A minus B is equal to sine of A cos of B. I want you to take note of that. Now, this is our third one. Yes. Now, all those three we have derived, they are going to be very important. But what should you take note of is that whenever we are going to be meeting a mixture of a sine and a cos, our two trigonometric functions we are going to be used are going to be sine and sine. Whenever we meet a sine and a cos, what we use is sine and sine. So please, you take note of that. That whenever you find that the integration that has been given has sine and cos, it means we use sine and sine. In case it is mixed sine, If it is sine, it means we use cos. In case it is cos, so in case it is sine, we shall use cos. In case it is cos, we shall still use cos. Members, are we together on that? Kindly just say yes, and then we start on looking at examples. You can just type in the chat, and then we start on the examples. Are we together on that? I want us now to dive into the examples. Okay. One person is saying yes, we are good. Okay. I think we are there. Okay. Now we are going to start on our examples. And our first number, we are going to say evaluate. And what is going to be our integral? Our integral is going to be the integral of sine of x, sine of 3x dx. Now, what is very important? What do you need to know? I need to go back and I ask myself, I'm going to write it here, that when I have sine of A, sine of B, what is this one equaling to? Because when you look at the two functions given, you have sine and sine. So for you, the only thing you need to remember that this one is the same as I have. What do I have? I put the bracket that it will give me cos. Or you can even go back. Feel free always to check. You go and check what is sine giving me. That sine, you come back here. It will give you cos A minus B minus cos A plus B. So that is the only thing you need to know. That is going to be your A minus B minus your cos of A plus B. That is the only thing you need to know. Now, what do I want you to take note? Now, for you, you don't need to suffer. Come look at the angles. The angle here is x. The angle here is 3x. Now, what is very important? Always, to make your life much easier, always choose your A when it is the biggest angle to avoid working with negatives or with negative angles. So choose your angle, one of the angles to be the biggest angle. When you look at the two, should be your A. So here I'm going to choose my A as 3x, and I'm going to choose my B as x. Now what do I do next? I'm going to just come and I substitute here. So I'll say this is going to be a half integral, a half into cos. Then what is my A? My A is 3x minus B, which is x, minus cos of 3x plus x. Then I'll have my dx. So this will equal to integral of a half into cos. Now here is 3x minus x, which is 2x, minus 3x plus x, which is going to give me 4x. Everything times the x. Now, what is the beauty? Now, the beauty is that this half being a constant, I can take it out. So I will say this is a half integral of cos of 2x minus cos of 4x. Everything dx. Members, let me know whether we are on the same page up to that point. Kindly feel free to unmute. Are we on the same page?
Yes, sir.
Okay, good. Now, what can I do next? Now, what I do next, I can now integrate the individual items. So, I can integrate cos 2x alone. I integrate cos 4x. So, I will say this is a half. When we integrate cos 2x, members, what do we get? Do you remember? We said when you have 2x, when we integrate this. Yes, Dennis?
Cos 2x is a half sine 2x.
Half sine of 2x. So members, please take note of that. What you do, for you you look at the angle you have, this angle, that when I differentiate this angle, what do I get? When I differentiate 2x, I'll end up with 2. So what I do, I just say 1 out of what I have differentiated. Then differentiate, integrate cos. When I integrate cos, I get sine. Then write the original angle. So here I'll have a half sine of 2x minus, still do the same, integrate, differentiate this angle. When you differentiate 4x, we end up with 4. So I write 1 out of 4. Now the next task is I integrate cos. When I integrate cos, I'll end up with sine. Then I write my original angle as 4x. Then everything plus c. So what am I going to do next? I'm going to enter the half that I had. This is a half here. So when I enter it inside, I'll have 1 out of 4 sine 2x minus this a half times the quarter, which gives us 1 out of 8 sine of 4x, then plus c. And then I will stop at that point. That is my answer. Friends, have we understood?
Yes.
Okay.
Yes, sir.
Okay. Yes. So first right, and then, oh, where Mogi, you can animate which negative?
Good evening.
Yes, good
Evening,
afternoon.
sir.
Yes, good afternoon.
The negative, remember when we are differentiating, when we are in the other identities, a signs, a cos gives us a sign, isn't it?
When you do what?
So the negative, if you can pull back on the other identity, you
This
can
one?
pull back on the other identity. I try to show you.
This one? Eh?
Of course.
I go back here.
The negative, up, down, 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 sir.
Here.
Down a little. There.
Oh, this negative.
So there is that negative.
Oh, now this negative, I said we can bring it inside. Eh? So in case for you left your thing like this, for you meaning you are going to first add and then subtract. You'll get the same answer.
So the order does not matter.
Yes, the order doesn't matter. For us, we have used this one.
Okay, then another question down on our answer. When I'm integrating a negative cos 4x, isn't the sign supposed to change?
Remember, when you integrate cos, you get a positive answer.
Yes.
So you get a positive answer. So it does not change. It remains the way it is. Hope that is fine. Okay. Yes. So I think now we can go on and try another number. Another number for us. Let me make another number. We are integrating. Yes. Cos 9x cos of 5x dx. Yeah, that's what we are integrating. Now, what I want you to identify, you go back to those identities. Ask yourself, what does cos and cos give me? After knowing what cos and cos gives you, then you come back. Or as you can even have it as your side work that I know. In fact, you don't need to cram. You can, as long as you have understood. So you know that whenever I have cos A, cos of B, this is the same as having a half into cos of, it will feel free. So in case you want A plus B, A minus B. So it is okay. But that is the first one we derived here. Where is the first one? Here. Yes. So you will come just back here in case you have not mastered them yet, so you say a plus b plus cos of a minus b. So, like I've told you, for you choose the biggest angle to be your a. So I'll say my a is equal to 9x, my b is equal to 5x. So meaning that when I have this integral of cos 9x cos of 5x, it's going to be equaling to the exact thing here. Don't even change. Integral of a half cos, let me put this bracket, a plus b, 9 plus 5x, plus cos, then you say 9x minus 5x, then everything times the x. So this a half being that it is common throughout, I can pull it and I say a half integral of cos. Then I ask myself, what is 9 plus 5? That is, what do we get? 14?
14.
14. So I'll say this is 14x plus 9x minus 5x. What do we get?
4.
4. So this is 4x. Then times the x. Now, when you reach here, you integrate the separate parts. You can, in fact, even those who want, you can even first separate, you say, as this a half, since it affects everything, I can even put this bracket. I say, let me integrate my 14x. Then also I integrate, this is the x. I integrate cos of 4x dx. So that is okay. But in case you know it already, no need for you to write this step. Then you start integrating a half into, when we integrate cos 14x members, what do we get?
Sine 14x.
Sine 40.
Out of
But
14.
1
Out of 14.
out of 14. 1 out of 14 sine 14x plus, when we integrate cos x, what do we get?
Sine 4x out of 4.
1 out of 1 out of 4 cos of what? 4x. Then what is remaining is plus c. Then you can bring in the half. So when I bring in the half, I'll have 14 times 2, which gives us 20.
28.
28.
Get
So we shall have our 28 sine of 14x
14x.
plus this half multiplies also this quarter. So you end up with 1 out of 8 cos of 4x, then plus c. Yes, someone has a hand. Yes, Dr. Pretty.
I thought it's supposed to be sine of 4x, not cos of 4x.
Oh, yes, you are right. I think we did not integrate. Thank you. I think we forgot, we did not integrate here. Let me correct it. We didn't integrate that second one. Hope everyone has seen that. Here, we had to integrate. We had to integrate this. Okay. Thank you. That is correct. So here we are supposed to have sine, and here we are supposed to have sine. Okay. Members, are we together? Any question? Are we good to continue? Should we continue, members?
Teacher.
Yes.
Okay. Now, you are going to try for me this one now. Everyone is going to try, and we see which answer do we come up with. Cos 3x, cos 5x dx. Evaluate. So let everyone first try out on your own. Dennis, have you finished?
Yes, sir.
Okay. Just share with us your answer.
My answer is 1 out of 16 sine 8x. 1 out of 6 sine 8x.
Plus?
Plus 1 for 1
Plus?
out of 4. Plus 1 out of 4 sine 2x.
Sine 2x. Okay. Let's wait for the rest and see what others are saying. Okay. Yes, Jemima?
I get the same answer.
You have the same answer. Okay. Then Jifta something?
Teacher, I have the same answer.
The same answer. Okay.
Yes.
Okay. Good. Good. Anyone finding some challenge? Anyone who is a bit challenged? Ben Carson, I don't know why you're getting negative. Ben Carson Jr., check out for that negative. Yes, okay. That is good, members. Yes. So, but what I expect, those who have integrated, or those people finding some challenges, I expect that inside your integral, here you have cos 8x and you have a 2x. Yes, I expect to have cos of 8x plus cos of 2x, everything times the x. So that's what I expect you to have. So in case you have not reached there, then that's where the problem is coming from. Okay, now we are going to advance and now look at what about when they mix. We have sine and we have cos. What will happen? Now we are going to start with this one. You have sine 9x, you have cos of 4x. We say that when you find that they have mixed two of them, it is an indicator that we are going to be using only signs. You can go back to your identities and then you find out what do they use. Did they use sine or they use cos? So when you go back and you check here, you can really take note that when you have a sine and a cos, you use always sine and you use sine. So, and I've told you that always for you that big angle, make it to be your A to avoid working with negatives. So I'll say my A is 9x, my B is equal to 4x. Don't mind about the order, whether it is cos or sine or cos, anything can work. So we shall say that this is the same as a half integral, then I bring in my sine. So it will be sine 9x plus 4x, then a plus sine of 9x minus 4x, everything times the x. Members, is that step fine?
Yes, sir.
Channel.
It's not, eh? I'm coming back here. We say that when we have sine A, cos of B, and we expand this is the same as a half sine of A plus B plus sine of A minus B. Now, since here we have sine and we have cos, and here we had sine and cos, and we ended up with sine and sines, we are going to substitute for our A and what is our B. And we say that our A, let it be that biggest angle, the largest of the two, which is 9x, and B is 4x. But here, when you are choosing, you can choose the other way around, it is okay. But the only challenge, you meet negatives. And if you don't know how to deal with them, they may confuse you. So what are we going to do? Now, we go back to our expression, what we are integrating, where we are seeing sine A cos B. In other words, here where we have sine of A, we have said is 9x. Cos B is the 4x. So this one is the same as having a half. So for you where there is F in this side, put it there. So I'll have sine of 9x plus 4x, then plus sine of 9x minus 4x. So we are substituting. So where there is the whole of this one, we substitute it with this. Are we together now?
Yes.
Yeah? The person.
Yes.
Okay. Now we are going to continue. So 9 plus 4, what do we get?
13.
You get
13.
13.
13.
You get
13x plus 9 minus 4, you get
5x.
5x, everything times the x. Then we can go on and integrate and have a half into, you integrate this is 1 out of 13. But since we are integrating sine, when you integrate sine, you get a negative. So here we shall have cos of 13x, sine, I'll integrate. So plus, but when we integrate 1 out of 5, when we integrate sine, we get negative. Then of course, of 5x, then everything plus c. But like we don't expect your answer to stay here where you have a plus and a minus, you simplify. So this one will give us negative 1 out of 26 cos of 13x. Then a half times the negative, this one being positive and negative yields a negative. So I have 1 out of 10 cos of 5x, everything plus. So we can first write that. Let me minimize the screen. I think some people were on the other screen. So let's first write and then we finished, members.
Yes, sir.
Okay. Okay. So let me scroll and then I give you one now to try out on your own. This one is for you to try out on your own, and then we see what we come up with. So what are we going to try out? We are going to try out when we have still the two different things. So I want you to try out this sine 3x cos of x dx. So let everyone try out and see how good you are now. Which answers do we have? Today, let me first choose and see. Chanel? Chanel, tell us, what do you have?
Yes, please.
What do you have?
I have negative a quarter
Negative a quarter
cos 2x
cos 2x
minus an eighth cos 4x plus c.
cos plus. Members, do we have that?
Yes, sir. It's true.
Okay. It's true. Okay, thank you. Anyone getting some challenge? Okay, I'm seeing people have that answer. Good. Okay. I think we are good in that part now. Okay. I think I need to give you one more that involves a squared. I think that is the one we have not made. One more that involves a squared, and then I'll assume that that section now is very okay. So now I have sine squared 2x cos of 7x dx. Then when you look at this one, is a mixture of two things. But here now, one thing you need to take note of is that they have mixed out some property that you need to take note of before you dive deep into the question. You need now to know, if I have sine squared 2x, how is it related in form of angles? Members, do we remember? I'm going to take you back. I know very well, this is just a reminder. When I have cos 2x, I know cos 2x the same as 2 cos squared x minus 1. Is that true, members?
Yes, it's true.
But also we know that cos 2x can as well be 1 minus 2 sine squared what? X. Is that familiar to everyone?
Yes.
Yes, sir.
Members, what if we have cos 4x? What is cos 4x equaling to? What if it's cos 4x? How is this identity going to change? Do you agree that it will become 2 sine squared 2x? Do we agree or no?
Yes, sir.
Yes. Friend, is this something common? Or we need to show how it comes about?
Shall we need to show how it comes about?
How it comes about. Okay. I'm going to come back here. And we are going to start still from here. We know that cos A plus B is the same as having cos of A, cos of B plus, sorry. So cos A plus B is equal to cos A, B. This is what? Minus.
Sine.
Hope that is fine, members. So when I have cos of 2x, I know that cos 2x is the same as having cos x plus x, because 2x means x plus x. So when I apply this, I'll have cos of x plus x equaling to, where there is a, I put x. So I'll have cos x, cos of x minus sine of x, sine of x. Because my a is the x and the b is the x. So this will give us cos squared x minus sine squared x. But you know very well, but we know that sine squared x plus cos squared x is equal to 1. So in case I don't want sine in, I will make it the subject. So my sine squared x will equal to 1 minus cos squared x. So I'll get this one, I replace it here. So it means that now my cos, this side I had 2x, is going to equal to cos squared x minus into 1 minus cos squared x. This one will give us cos of squared x minus 1 plus cos squared x. So cos plus cos is what is giving us the 2 cos squared x minus 1. Now that is the first one. That's where it comes from. However, since we have 4, we are going to go back. And I said that when I have cos of 4x, this is the same as having cos of 2x plus 2x. So what will equal this one? We shall have cos of 2x, cos of 2x minus sine of 2x, sine of 2x. What will this one equal? This one will become cos squared 2x minus sine squared 2x. I come back to my trigonometry. I know very well that we say that when we have sine squared x plus cos squared x, this one will equal to 1. Even if this angle changes and I have sine squared 2x plus cos squared 2x, this one will also equal to a 1. This is true for any angle. So do not only take it that always must be one angle. No, it can be a double angle. As long as those two angles are the same, you remain with the same thing. Now, since I want to eliminate sine, I will say now my sine squared 2x will equal to 1 minus cos squared 2. Now I'll come back here where the sine squared x, I put this. So we shall come up with cos squared 2x from here minus, we substitute, which is 1 minus cos squared 2x. I'll open up the brackets. I have cos squared 2x minus 1 plus cos squared 2x. So cos squared x plus cos squared 2x gives us 2 cos squared x 2x minus a 1. So that's where it comes from. So that's where it comes from. So now in case I wanted sine, it means that now I'll come back to my formula here, because we had reached here that cos 4x is equal to cos squared 2x minus sine squared 2x. If I want cos squared 2x, I want to remain with sine, then I will substitute 1 minus sine squared 2x minus sine squared 2x. Because I know the whole of this one is the same as cos squared 2x. So when I collect like terms, and when I have removed these brackets, I remove this bracket here, and I remove this bracket here, it means that I'm going to remain with 1 minus this. There is a silent one and a silent one here. So minus 1 gives us a 2 sine of squared 2x is equal to cos of 4x. So since I want sine squared 2x, I can bring it this side. I take the other on that side. So this will become 2 sine squared 2x equaling to 1 minus cos of 4x. Then I remove that 2 by dividing. So meaning that my sine squared 2x is the same as having a half into 1 minus cos. Members, is that fine?
Yes.
Are we on the same page? Yes. Are we on the same page? Let me check in the chat. Okay. Okay. Hope, Jemima, you have understood how it comes about.
Yes, teacher.
Okay. Yes, Dennis Ochen.
Yes, that one I think is too long. We just get the identity of cos first right for me.
Mm-hmm.
So we just say from cos 2x, which is same as 1 minus 2 sine square x. So the best thing apart from going that far, we just increase the angle. We increase the angle will be now, when you multiply, increase the angle by 2 in order to get cos 4x. Now be cos 4x the same as 1 minus 2 sine square 2x.
Yes, this one is
then make sine square 2x the subject only, apart from going that far.
Oh, okay. Yes, that is very true. That is very true. So I wanted to just show them how it comes about, because at times when you just take it in, but this is the shortest approach. The moment someone knows this, even if the angle here is 8, even if they put for you here 8x, even if they put for you 12x, whatever angle, as long as you know what is that multiple they have multiplied with the angle, then you can be able to get. So now we can go back to our question. I'm coming back here now to our question. So our question wanted us to integrate sine squared of 2x cos, I think, sine squared 2x cos of 7x dx. So here, I expect you that before you carry on anything, first eliminate this squared. So we set into sine squared 2x, we have obtained it as 1.5 into 1 minus cos of 4x. Then I'm multiplying this time with cos of 7x dx. So then you can open up your bracket, but this half being common, I can even, being that it is multiplying, I can pull it out. So I have 1 minus cos 4x into cos of 7x dx. So when you open up the brackets, you have a half integral of cos 7x minus cos of 4x, cos of 7x, everything dx. Now, what I'm going to notice is that here you are going now to bring in what we have been looking at. It is very easy for you to integrate this, but now this one will require us to use the factor formula. So now I want you to separate your integrals. Have integral of cos of 7x minus a half integral of cos of 4x, cos of 7x dx. Here this can also be. So I want you to integrate for me that, and we see what we come up with at the final answer. So let everyone now try. Jemima.
So I have a question.
Yes.
From a half integral 1 minus cos 4x brackets cos 7x. So that's
Yes.
the next step. How did it become that?
Okay. Jemima, are you saying this? I have 1 minus cos 4x. Then here I have cos of 7x. Open for me the bracket.
Oh, yeah. No. Yes, I've understood now.
Okay.
Thank you.
Yes, Chanel.
So I have a question.
Yes.
Is that the only way to go about the number? Like the only method you can use?
Oh, do you have another approach you have thought about, Chanel?
No, I'm just inquiring.
Oh, okay. Yeah, it is now the easiest. Reason being that the two angles, these angles are different. If the angles were the same, we could use another approach. Is it so hard?
No, it's fine. Thank you.
Okay. Yeah. But if the angles were the same, we could just use the change of variables. It could work. Yeah. Ben Carson has got the answer. I think Dennis Ochan has also got the answer. Okay. Ochan, which answer are you getting?
I got 1 out of 14 sine 7x minus 1 out of 22 sine 11x, then minus 1 out of 6 sine 3x plus c.
Okay. Okay, let us wait for another one. There's something I'm not seeing. Same answer as Ben, 1 out of 22. Members, I want you to look there is something I think we are forgetting. There is something I think we are forgetting. Yes. I think Moji has brought it out very well. Yes, thank you, Moji. Yes, just add on a C. Yes, members, it is 1 out of 44. Check out and see. Okay, 1 out of 44. I don't know whether Carson, you have been able to see it, and the Ochan. Is it coming out, members? Is it coming out? It seems that I think the silence is showing me that as if somewhere it's not getting there. Chanel, is it coming out? Jemima?
Not yet, teacher. But I'm trying.
And in fact, what even you do at times, when you find out like these can be section B numbers, for you even to be at times on a safer side, you can integrate it in parts. You can integrate it in 2 different parts and then say, let me first work out this part, this one over half. But in case you want to carry the negative, no problem. Of course, of 4x, cos 7x. Then you have to remember that when I have cos and cos, that one yielded for us a half. So that one inside I have negative a half into, I'm just working out this. I know it is going to be a half integral of cos, that is the 11x, that is a plus cos 7 minus 4, which is 3x, everything dx. And then this negative a half times this one is what gives us negative a quarter. Then I have integral of cos 11x plus cos of 3x dx. Then I can now do my integration. So I have negative a quarter into 1 out of 11 sine 11x plus 1 out of 3 cos 3x. So when I multiply through by negative a quarter, that's how I end up with my negative 1 out of 44, because 11 times 4 will give me negative 44. So that's where we got it, members. Those who are not getting the 44. The 44 came from that point there. So this one will give us negative 1 out of 44 sine 11x, negative times this 4 times 3 is 12. I think, are you on the same page now?
Yes.
Yes, teacher.
Okay, okay. But please do not forget, they can as well give you these numbers with limits. Yes, they can put limits, and therefore you need to know how to calculate. So I'm going to just give you, these are just
Excuse me,
your
Mr. Kazu.
Yes.
I had a question.
Okay.
Could you please go back to the start of the question?
Yeah.
Yes, so I was asking on that step after substituting for sine squared 2x, and you have a half into 1 minus cos 4x, cos 7. Can I open brackets and I have a half minus a half cos 4x, cos 7x, and I integrate it in parts like a half minus a half cos 4x, cos 7x. Is it correct?
I beg your pardon, now you have opened the brackets.
I see this step of a half, yes, that first step.
And you do it?
I open and I get a half minus a half cos 4x cos 7x.
Like that.
And I integrate that in parts. Is it okay?
Not really. Why? That this cos of 7x affects everything inside the bracket. So when for you have opened, it has only affected cos x, it has not affected this. But if you had put it like a half cos 7x minus a half cos of 4x cos 7x, that one is very fine.
Okay, thank you, sir.
Yeah. Yes. That is your work to try out. In your free time, you try out a number. Yes. So you let me know. Have you taken a screenshot? But I will share again, no problem. Should we continue?
Yes.
Now, we are going to look at the next one, what we call tan and sine substitution. Tan and sine substitution. Now, what do you need to know is what we call our tan and what we call our sine. How do we deal with them? That's what we are going to deal with here. I understand that when you check the mathematical tables, let me check whether you have them here. I have them here. When you check the mathematical tables, at times you'll find many of those formulas given to you. And then you need to just substitute. But always, I encourage you that learn how it comes about. Because once you learn something now, in the future, it is going to be very important. Because the more when you are advancing in these subjects, they will not give you those formulas and the rest. So they expect you to have learned. And it is now better that you learn them when you are still very young, such that they can stick. So here, I'm going to look at two things. When we are looking at tan, I want you always to observe that tan is always going, when you look at the denominator, when you are looking for, when should I substitute in for tan, it's when we have a positive in the denominator. When it comes to sine, when do we substitute in sine? That's when we have negative in the denominator. But how does that negative look like? Oh. Now, when it comes to tan, most times, whenever you find an integral of the form 1 out of a squared plus b squared x squared, the moment you notice that this is a plus down here, then it means that you are going to use tan. But if you find that your integral is maybe an integral of maybe 1 out of the square root of 1 minus maybe x squared, something like this, maybe a minus x squared. The moment you notice that there is a minus down, then that one shows you that you are substituting in for sine. Yes. So that is the difference between the two. That when it comes to tan, it's always going to be a positive. When it comes to sine, it is always a negative. But how do you notice? Yes, Chanel.
So for both substitutions, they are always in division form.
Yes, they are always in the division form. One
so
out
if
of
it's a multiplication, tan can't be used.
Yes, okay, it depends on the number. But when it is multiplication, then you think about another approach.
Okay.
Okay. Okay, I think now we are good to start. Allow me that I start with an example. Then I show you. But which identities are going to be very common? The two identities that we are going to be applying here, we know very well that when I have one, okay, let me not teach you. I don't want you to cram. 1 plus sine squared plus cos squared x, we know that this is 1. In order for me to get tan, I know tan is sine out of cos. So when I divide by cos squared x out of cos squared x. Here, sine out of cos is equal to tan squared x. Cos out of cos, that one is equal to 1. And 1 out of cos is the same as sec squared x. Now, your task downward, when we are to substitute in for tan, is to make sure that we come up with an identity of this nature somewhere. So, and this identity, you are noticing, it has 1 plus tan squared. I can write it like this, is equal to sec squared x. So when you are looking at your denominator, for you must ensure that you have 1 plus, 1 plus, 1 plus. That's when the identity will work out for you. When it comes to using sine, when you're substituting sine cos, what do you need to remember? You need to just remember that always sine squared x plus cos squared x is equal to 1. So this is the identity we use. So those are going to be the major identities we are going to use for this part. Members, are we on the track?
Yes.
No.
Okay. But what I want you to obtain is this identity, that 1 plus tan squared x is equal to sec squared x. And that when it comes to tan starts with a plus. I will always apply it when I have a plus in my denominator. That sign is the one that I apply when I have a negative in the denominator. Yes, Luther. Bukenya?
How about the square root? How about the square root?
Oh, that square root will go away. It's going to go away. But for you, what you need to know, down there, that square root is important to eliminate the squared. Yes, but we are going to look at an example. But it is also important. But for when it comes to sine, cos, that square root is very important. It should be there.
And for tan?
For tan, the square root is not important.
Excuse me, teacher.
Yes.
I wanted to know, now like for that first number where we have a squared plus b squared x squared, if we had like the square root of that denominator and there is a what? And there is a minus in the middle, could we have substituted tan or sine?
Sine. The moment you say square root, there is a minus down, that is sine.
Okay, thank you.
Okay. Now, let us members, we are going to understand further using the examples. So find the following integrals. Now, the first one we are going to deal with is having 1 out of 4 plus x squared dx. Now, what do I want you to always do? The first thing always, I want you to look at what you have in your denominator. That in my denominator, I have 4 plus x squared. But what identity am I going to use? My identity is 1 plus tan squared x is equal to sec squared x. Now, what are you going to do? I don't want you to cram. Don't cram that, I am supposed to do this, I'm supposed to do it. No, do not cram. So the first thing always you do is to ensure that what you have in your denominator here can yield for you a 1 plus something. That is the first thing. So take an example. In our denominator, we have 4 plus x squared. What am I going to do? I'm going to say that 4 plus x squared, this one is the same as, when I pull out this 4, I can have 4 out, I have factorized out 4. When I factorize out 4 out, here I remain with the 1. Members, is that fine?
Yes.
Plus, here we shall remain with x squared out of 4. Members, are you seeing that?
Yes.
Is that clear?
It's true. Yes, sir.
It is okay. Now, this is going to be always your first task. And once you accomplish that, it means you are going to pass that number. That's the first thing. Now, what do? I'm going to come back here to my integral, and I write it as 1 out of 4 into 1 plus x squared out of 4, everything dx. Now, this one I have in the bracket is what I'm going to compare with. So I'm going to come and I say, like here, we are using like, we compare or we equate. So what am I going to say? I'm going to say that 1 plus tan squared x is equal to 1 plus x squared out of 4. Members, are we together on that?
Yes.
So what is going to happen? Are you seeing this one and this one reducing?
Yeah, I see.
Are we seeing it? So meaning we are going to remain with tan squared x is equal to x squared out of 4. Now this one being a squared and these ones are squared, I can get the root of a tan. So I'm going to get a root, I get a root. So here I remain with tan of x is equal to, when I get, like I have a square root of x squared out of 4, meaning is I can get x squared out of root of 4. So square root of x squared is x and square root of 4 is 2. So I will end up with x out of 2. Members, are we together up to that step?
Yes, we are still together.
Yeah. Ruth, are we together?
Yes, teacher.
Okay. And Chanel?
Yes, teacher.
Okay. Now, what are we going to do? Now, like we said, there is a step where I have to, this step here I've cancelled out. We said that where there is 1 plus x squared out of 4, we are going to substitute it with 1 plus tan squared x. Now, the next one is where we have our dx. But now, what are we going to do? One thing I want you to know is that since we are dealing with x, when we are letting, we don't use the same x. Here, we are going to use another variable. So instead of here, I did not notice we are using x. So here, we are going to change. Allow me that we use theta. So here, this one it will remain as x, but this one of tan is going to be theta, is going to be theta. Hope that it shouldn't confuse you. Is that fine? I hope that is okay. Are we together on that?
Yes.
Is that fine? So this one is going to be theta. Then this is going to be the x. Now our task, since we have tan of theta is equal to x out of 2, what are we going to do? We are going to differentiate. When I differentiate tan of theta, members, what do we get? Sec squared theta, the theta is equal to x out of 2, we'll end up with a half dx. Now, since you want to substitute for dx, you make your dx the subject. So I can multiply it throughout, so I'll end up with 2 x squared theta is equal to x. Let me hope we're okay. Now I'll come where there is the x, I put 2 sec squared theta. So I'm going to come, I have my integral of 1 out of 4. But I know very well 1 plus tan squared theta is the same as sec squared theta. Times my dx, I have obtained 2 sec squared theta. So what is going to happen? This sec and this sec will cancel. I have a 2 here, by 2, 1, by 2, 2. So in that integral, I'm going to remain with 1 out of 2 my d theta. So that is what I'm going to integrate. So when I integrate, I'll have 1 out of 2 theta plus a constant. Now, after getting this, I go back because we said somewhere before we differentiated that our tan theta was equal to x out of 2. Since you are interested in theta, it means that your theta, when you make it the subject, we shall have theta is equal to tan inverse of x out of 2. So where there is theta, we shall put tan inverse x out of 2. So here I have 1 out of 2 tan inverse x out of 2 plus 6. Members, is that fine?
Yes.
Yes. So that is your answer. Yeah, it may look a bit complicated, but we are going to do 4 numbers. By the time we shall finish, we shall be at the same page. So you first write. So, but what is important is you ensuring that you are forming that 1 down. 1 plus, 1 plus. Though I can also show you another approach, but let us first master 1. When you finish, you let me know. Okay, I think people are finished. Has everyone finished? Okay, okay. Let us now do another one. Yes, but for you, do not fear, look at them very well, and then your task is to ensure that you have a 1. I have another one here that we are going to do. I have integral of 1 out of 1 plus 16 x squared dx. Now, the moment you look in your denominator and you find that they have already given you 1 plus, there, be happy that that one is very easy now for you to start with. So what do you do? So you are going to just say, let 1 plus 16x squared equals to 1 plus tan squared theta. Members, is that step fine? Are we together there?
Yes.
Now, members, are you seeing 1 and 1 going already? Because this is 1. When you collect like terms, this one and this one will go. So I remain with 16x squared is equal to tan squared theta. Are we on the same track?
Yes.
Now, the next thing you do is to get tan. So this being a squared, I'm going to get a square root, get the square root. So I know square root of 16, square root of x squared can be obtained. This side, square root of tan squared is tan theta. Square root of 16 is 4. Square root of x squared is x is equal to tan of theta. Members, let me know whether you're on the same page.
Yeah, we are still together.
We are still together. Let me check. Jemima, are we on the same page? And are we on the same page? Ben Carson? Chanel?
Teacher, we're on the same page.
Okay. Emilia Joy?
So we're on the same page.
Okay. Now, the next thing we do, since we want the x, it means that we are going to differentiate. So I'll say 4 dx is equal to, because when you differentiate for x, you get for dx, is equal to sec squared theta d theta. Since we want the x, I'll make it the subject. So I'll divide by 4, I divide by 4. So I'll end up with dx equaling to 1 out of 4 sec squared theta d theta. So after you obtaining this, just come back here in your original expression, and you say this is 1 out of 1. We said initially our first relating was 1 plus 16x squared is the same as 1 plus tan squared theta. So down here, I'll have 1 plus tan squared theta, then times my dx. I've got my thing as 1 out of 4 sec squared theta d theta. But I know very well 1 plus tan squared theta is the same as sec squared theta. Then times I have my a quarter sec squared theta d theta. For you to prove, always you find that in the denominator and numerator, there is something cancelling. So this and this will cancel. So when you observe very well, we are going to remain with, this one will give us an integral of 1 out of 4 d theta. Now your task is to integrate. So I'm going to come now and I integrate that. So this is when I integrate a quarter d theta. Members, what do we get?
A quarter theta.
Yes, a quarter theta. So I'll have a quarter theta plus c. After obtaining this, I'm going to just go back here. I look out for expression. So since we had 4x is equal to tan of theta, since I want theta, I'll make it the subject. So I'll say theta is the same as tan inverse of 4x. So I'll come here where there is theta, I substitute. So I'll have 1 out of 4 tan inverse 4x plus a constant. Always your answer must be in terms of x, since our original thing was in terms of x. Members, have you picked something?
Yes, teacher.
Okay. Yes, sir.
Okay, let's try. Well, when you finish, you let me know, and then we'll continue. Okay, paper saying we continue. Okay. Has that one finished? Are we good to continue?
Yeah, we can go to go.
Okay. Now, we are going to have another one. So another one I'm going to have is still an integral of 1 out of 3 plus 4x squared dx. Now, for you, the moment you look at your denominator, when you have a plus, you are seeing a squared on the variable you are differentiating. Then just know I'm to use my tan. So, okay, Faith, which dx? Faith? Okay. So, what are we going to? We are going to let. So I will say let 3, but we said that before you let, what you are going to let with, you must have 1 plus something. So since I have 4x squared, we say that you make sure your expression is in the form of 1 plus that thing. So here we say that the moment you find that here it's not a 1, you make sure you make it a 1. So how are we going to make it a 1? We shall factorize out that same number, which is 3. So I'll factorize out 3 into, I remain here with 1 plus, since I have removed the 3, here I will get 4 out of 3 x squared. Members, is that fine? That step fine? Are we together how we have factorized out the 3?
Yes.
Because when you bring back the 3 inside, you come back to the same thing. Now I can first come back here and I substitute and I say this is the same as 1 out of 3 into 1 plus 4 out of 3 x squared dx. Now this one, since I don't want this 3, I can write it as 1 out of 3 integral of 1 out of 1 plus 4 out of 3 x squared dx. Now when I look at my denominator now, I can really take note that it is 1 plus something. Now, after getting this is where now we are going to let to your tan. And then say that now let 1 plus 4 out of 3x squared equals to 1 plus tan squared theta. When you look at this step, 1 and a 1 is going away. So once those ones go, it means you have 4 out of 3 x squared is equal to tan squared theta. Now, what is the next step? The next step is for you to get your tan. So you get the square root. I'll get the square root this side. I'll get the square root this side. However, I want you to pay attention now this side, because I can have the square root of 4 out of the square root of 3 and the square root of x squared. But you know, square root of 4, we know that is 2. Square root of 3 does not exist. So it means that you leave it inside 4. You don't put points. Square root of x squared is x, so you leave it as x. So meaning here we shall have 2 out of root of 3 x is equal to tan of theta. After that step is where we go back and find our dx by differentiating. So I have 2 out of 3 x is equal to tan of theta. So when we differentiate, we shall have 2 out of root of 3. When I differentiate x, I'll have dx is equal to tan theta. When I differentiate, I end up with sec squared theta d theta. Since I'm interested in dx, I'm going to remove this root 3 by multiplying root 3 on both sides, and then I divide by 2. So my dx will equal to root of 3 out of 2 sec squared theta d theta. Members, let me know whether we are together up to that level. Are we together? We are together?
Yes, teacher.
Now we come back here. We are going to come back here. and then we substitute. So I have 1 out of 3 integral of 1 plus 1 plus 4x from here, we said is the same as 1 plus tan squared. So 1 plus tan squared theta times my dx, which is root 3 out of 2 sec squared theta d theta. But you can note that 1 plus tan squared theta and sec squared theta, it is the same thing. But in case you want for, you can even first continue and say this is 1 out of sec squared theta times root of 3 out of 2 sec squared theta d theta. Then you cancel these ones. So after cancelling, you are noticing that we are going to remain with 1 out of 3 integral of root of 3 out of 2 d theta. So you go on and you integrate. So this will be 1 out of 3 times root of 3 out of 2 theta plus a constant. So root of 3, so this is root of 3 out of 6 theta plus a constant. So your task is to put in what your theta is. So our theta, when you remember from this point here, we had 2 out of 3x is equal to tan of theta. So meaning that to get my theta, I'll get the inverse. So my theta will be equal to tan inverse of 2 out of 3x. So I'll come here and I say this is root of 3 out of x tan inverse of 2 out of 3x plus constant. Yes, let me know whether you have picked something.
Yes, teacher.
Has everyone picked something?
Yes, teacher.
Oh, yes. Oh, don't forget there is the root here. There is the root. This was root 3. Don't forget this is root 3. This is root 3. Yes. Hope you are saying it. It was root of 3. I had skipped it. There is root of 3 here. So don't forget to put it there. So we can first write. And I give you one number to try out and we see whether we are at least we are somewhere. It's a bit tough, but it is doable. It is very doable. When you finish, you let me know, and then we try out some numbers. I want us to try 2 numbers before we leave, and we see whether members have picked something.
It's done.
Okay, if I've finished. Okay. I can now give the numbers, and then we try out. The first number that we are trying out is the integral of 1 out of, we are trying 1 out of integral of 2 plus x squared dx. So let us first try that, everyone. Try it on your own, and we test whether at least you have picked some idea. Okay. Okay. So I think Dennis has finished. Okay, Dennis, let's give them some few minutes and we see what they're coming up with. Okay, I'm seeing that another person has done. Okay, those are 2, 3, in fact. Emilia Joy, have you finished?
Yes, teacher, I have.
Okay. Share with us the answer you have.
I have root 2 out of
Root of 2
I
out
have
of?
I have side 2 out of 2 and inverse x out of side 2 plus
I'm not getting, you have root 2, I've had root of 2.
I have the side of 2
Side of 2,
and inverse
Sine inverse, tan
tan
inverse.
inverse
Okay.
x out of root 2
X out of root of 2
plus c.
plus E.
At the start, it's root 2 out of 2.
Plus what? Root of 2 out of 2.
Yes. No,
Where did you get that? Yeah?
So my answer is root 2 out of 2 tan inverse x out of root 2 plus c.
So, like this, the one I've written, Is it like that?
No, no, at the very start, it's root 2 out of 2, just root 2.
Root out of 2,
Yes.
Okay.
Like that.
Okay. Members, the answer is okay. Yes. Do we have that answer, everyone? Do we have that answer?
Yes.
Yeah. Okay, good. And please, I don't want you to get it that always up here, it's supposed to be 1. It can be any other thing. So let me just put there a digit today. Let me put 3. Okay. Yes. So let us first try that. In case you didn't get the other answer, you can let us know. Okay, same. Done. Okay, pretty Dennis. Okay. Now let us try that. Luther, did you get the same answer?
Yes, teacher.
Okay. What about Mutebi? Wycliffe, did you have the same answer? Jemima, did you get the same answer?
Chami, my answer is a half tan inverse x out of root 2 plus c.
Okay. What did you let Jemima?
So I did tan squared theta is equals to x squared out of 2.
Okay.
Then
So
I
you
found
first.
the root. Yeah,
So
that's what I did.
You did this,
Yeah.
huh? And then you
Yes.
had x squared out of 2 is equal to tan squared theta.
Yes.
Then you
Then
got
tan theta.
is equal
Then I
to.
found square root. Yeah.
Then when you differentiated, you had 1 out of root of 2 dx is equal to sec squared theta.
Oh yes, I seen my mistake there.
Okay. Okay. Seems some people have got the answer. Finish the second one. Finished. Okay. Are we getting that answer, members? Someone is saying root 3 tan inverse x out of root 3. Yes. Yes, finished. Do you have that answer?
Yes, sir.
Oh.
Yes, teacher.
Okay. Luther, read for us your answer. It is?
Charlie said finished.
You have not. Okay. Okay. Those who have finished, let me give you one more. One more. And then we see what to do. Maybe one for tan. And when you are dealing with tan, another thing I'm going to remind you, you need to remember what we call complete in squares. You need an idea about that. So what the number I'm giving you is the number even that has. So, but that one we shall look at it as time goes on. So let me even put some limits for this one. And then we try it. We try it.
Oh. She slips down.
Yes? We are trying that number in purple. It's the one we are trying. First integrate. After integrating, then we get there. But in case you are stuck somewhere, you can let us know and we hope for the previous number. Allow me to pause sharing a minute as you continue. So before you put in the limits, you can first share with us the answer you get. Before you put in the limits is √3 out of 2, the lower limit. Let's hope everyone is trying. Yeah. Oh, the limits, Robinson, the limits are root 3 out of 2 for the lower limit, and then the upper limit is 3 out of 2. 3 out of 2. I'm interested in the part before you put in the roots. Before you put in the root, what you get after integration. Okay, someone to share with us, anyone who has finished to integrate. What answer do you have? Yes, Kusima.
Teacher, I have.
You have?
I have root 3.
Root 3.
Tan inverse.
Tan inverse.
Of 2x.
2x.
Out of root 3.
Out of root 3. Okay, okay. Yes, members, ensure that you have that answer. Yes, make sure that is the answer that you have. That should be your answer. That should be your answer. In fact, I think even here I can say, let me see whether I can tell even two. Yes. In fact, even I want you to prove that your answer is going to be pi root of 3 out of 12. Yes. So those who have finished, check and see whether you can get that answer. But in case you are not getting root 3, or my final answer, okay, your final answer. Let me ask you now, since I want now us to get a good answer, kindly check and see that we get that. Check out and see. I have the pi, Chanel. Okay, Chanel, what else do you have? Do you have the root 3? Chanel, do you have that root 3 appearing?
Yes.
So do you have that same answer or it is a bit different?
I don't know if I simplify, I can.
Okay. Okay. Try to simplify and see whether you get that. In case you come up with this answer, you let us know. Yes, from here, put root of 3 out of 2 and put 3 out of 2. Anyone coming up with an answer close to that? Okay, pretty. Can you leave it in pi format? And we see whether you get the same. Pretty. Yes. Now that pi is coming from where you got tan inverse. Because when you get tan inverse gives you an angle. And since we are dealing with the trigonometry, we shall write our angle in terms of pi or radian. So that's why we leave the pi there. Yes. So I expect you to have pi. Okay, Chanel, has the answer come out like that?
Yes, teacher.
Yes, okay. Who else has the same answer? Who has something close to that? Joy, is the answer like that? Emma, Faith, Jemima, Luther, Mpela. Is that answer like that, Muchi?
Yes, teacher.
Okay. What about Albert and Trinity? Ben Carson and Brenda? Do we have that answer?
No, teacher, how do we put our answer into pi?
To pi. Oh, okay. Now I'm going to come back here. Mainly when it comes to tan inverse, allow me to only deal with tan inverse. So you have tan inverse of 2x root of 3. So when you substitute in 3 out of 2, you'll have tan inverse of 2 times x. Now, in case our x, you have used the 3 out of 2, then out of root of 3. So these 2 and these 2 cancels. So you remain with the tan inverse of 3 root of 3. Now, what is going to happen is that since you are dealing with the angles, what you do, you are going to place 3, when you place your calculator, 3 divided by root of 3, and you place tan inverse of that, you are going to get your answer as 60. Now, when you get 60, then turn your 60 into pi. So how do you turn by pi? In order for you to change anything to pi, what you do, you multiply that angle you have by pi and divide it by 180. So that's how you turn. You multiply by pi divided by 180. This is 0 and the 0 will cancel by 6, 1 by 6, 3. So you end up with pi out of 3. Yes. People who are getting points, those are the people who have converted their calculators into radians. So when you convert radians, you'll get that 1.33, of which also the answer is okay, no problem. But at times they may ask you to prove. Yes, but once those people have left their calculators in degrees, 3 out of root 3, you end up with 60. But this is an angle. And since we are dealing with the trigonometry, we convert it. So you multiply times pi out of 108. So that's how they get there. Hope you're on the same page.
Yes.
Okay. Okay, allow me. Yes? Okay. Okay, so we are going to end here. I'm going to ask you to first try out the first numbers, to try out about 3 of them or 4. You can share in my inbox. But I'm going to send some for integrating using the tan substitution. I'm going to share some numbers with you such that you can try. I will send on the WhatsApp group such that you can try out in your free time. Otherwise, let me wish you a good evening. Ben Carson, is there a problem?
So how do you get the 60?
The 60? The 60. Oh, the 60 came here. Like when you have this.
Yes.
So when you place tan inverse of 3 root of 3 on your calculator, what do you get? Which angle do you get?
1.0.
Yes?
1.047.
Oh, now your calculator is in radians, eh?
Oh, I get it.
It is in radians. So here we are calculating in degrees. Yes, but you can cross-check. Also try number. Mogi, What does 2019 say number 12D? Maybe you can tell them and they try out. Those who don't have question banks. You can tell us what the number is. Even 2018, Yes, read for us those numbers. The first one is 20 what? Just read for us the number and then members can try out.
2019, they were saying evaluate the integral dx over. So I think this one is for tan substitution.
Okay,
over x squared, the root of, in brackets, 25 minus x squared.
Oh, okay. Now this is, yes, like we said, when you say minus, this is for sine.
Yeah.
Yeah, this is sine. But those four, if at all you have picked the idea of what? Tan, also for sine, you can first, even you can self-teach yourself. We use the same idea. There's nothing much that is going to change about it. The only thing you need to know that still for sine, you first remove now this 25, you first remove it. Like you can say integral of the x out of x squared. Now to remove this 25, I'll have my square root, so I can say 25 into 1 minus x squared out of 25. So once you do like that, you'll have the integral of the x out of x squared. Now here, since I'm multiplying two numbers, I can get the square root of 25. So I can have the square root of 25 separately, and also I have 1 minus x squared out of 25. So now for this case, what you do, instead of letting 1 plus tan, here instead of, sine squared x plus cos squared x is equal to 1. So it means that here you'll say that sine squared x will equal to 1 minus cos squared x. So here, instead we let 1 minus cos squared x. So you say 1 minus x squared out of 25 is equal to 1 minus cos squared x. So you notice the 1 and the 1 cancel, so you remain with negative x squared out of 25 is equal to cos squared x, but negative. The negative and the negative cancel, so you remain with x squared out of 25 is equal to cos squared x. So you get the square root, get the square root. So you end up with x out of 5 is equal to cos x. So after getting this, and then you go on and differentiate. So you have x out of 5 is equal to cos x. So here you have 1 out of 5 dx is equal to, when you differentiate cos, you get negative sine x dx. Sorry. So this is supposed to be, I think I related again. This is supposed to be theta. This is theta. This is theta. This is theta. This is supposed to be theta. This is supposed to be theta. And this is supposed to be theta. Sorry. Now, to get your dx, you say dx is equal to negative 5 sine of theta d theta. So you come back here and you substitute. So you have the integral of dx. Now dx, I write negative 5 sine of theta d theta divided by now x squared. To obtain your x squared, you substitute here. So x is equal to cos theta. You multiply by 5, you get x is equal to 5 cos of theta. Since you have x squared here, it will become 5. That is what? Cos squared of theta. But since it is squared, it becomes 25 cos squared theta. Then inside the integral, you are going to have 1 minus x squared out of 25, which was 1 minus cos squared theta. 1 minus cos squared theta is sine squared theta. Square root of sine squared theta is sine theta. So in other words, that sine and the 1 down, they will cancel. So you remain with 1 out of 25, but also there is a negative, this one's cancel, but like that. So, but almost the same idea. But here, instead of letting, like the way we have been letting, we shall always let 1 minus cos squared theta. But we shall look at this. We shall look at sine substitution. But you can suggest a morning, one morning before the week ends. One morning that can work, and then we can use the morning. Probably maybe we can say any time that favors you, either 5 or 6 or 7, around there, but not beyond 9.
Chat 5.
5. Okay. How many can manage 5?
You can.
Okay.
Yes, teacher. Make it
Okay. 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 I think we shall get a day within this week, and then I will tell you one of the days. Whether it can be even Friday or Saturday, one of those days, and then we can go through sine and cos. Yeah. So that's how you did. But you can try it on your own by substituting 1 minus cos whenever you meet those negatives. Yeah. So we shall start from there unless someone has a question. Oh, those without pi, okay, it depends on how the question has been set. In case it's a proving number and they want it in a given format, always follow that given format. Okay, I think we are good. Yes, Jemai, you a question? Okay.
No, teacher, I forgot my hand up.
Okay, you can lead us in a word of prayer, no problem.
Okay. Heavenly Father, one thank you for love and care you've given us. One thank you for blessing and protecting us. One thank you that you enable us understand this lesson. May you please bless and protect the teacher who has taught us, oh God. And we pray that we're able to go an extra mile and do more revision about the topic we've done, oh God. And we pray we're not able to forget it, oh God. We pray for a very beautiful evening. And we pray that we're able to pass highly, oh God. Just we also pray for supernatural wisdom, knowledge, and understanding upon our lives, oh God. Just am afraid. Amen.
Yeah, amen.
Amen.
Yeah. Bye, everyone.